John and Peter had $1,000 all together at first. John spends 1/5 of his money and Peter spends 1/4 of his money. They had a total of $787.50 in the end. How much did John have at first? So we notice that there are two changes involving John and Peter, and these two changes involve fractions. All right, so do take note that these two fractions denominators do not represent the same value because they simply refer to two different people's money at first. So what we're going to do is we can record this down in a before change after way. So let's start off with $1,000 at first. So $1,000 is what they both had all together. So I just begin with an equation like this. And we go on to show an arrow to represent the change. So John spends 1/5 of his money. Hence John minus 1/5 in this manner. Now remember, when you have a change involving a fraction, you can rewrite this as a mini BCA ratio at the bottom here. All right. So B stands for before, C is change, A is the after. Now using the before change after ratio, using this 1/5 here to translate it here, your 5 units represents the before, right? The John's before. Minus 1. So out of 5 units, he spends 1 unit away. So that is the change. And in the end, the after will be left with 4 units. And we are going to do something similar for Peter. Peter spends 1/4 of his money. Likewise, a BCA ratio. So 4 units is Peter's before. Out of 4 units, he spends 1 unit away, minus 1, and he's left with 3. In the end, they had a total of this much money, hence we record it down in the after section. Okay, so first step of recording data done. Second step is to identify your common base between the two ratios. All right, so let's look at the two ratios. Should the before be the common base? All right, so if we look at the before, right, that means we are saying that John before and Peter before, should they be the same? So what we know is they shouldn't be the same because we have no idea, or rather I would say the question did not give us information to say that they're the same at first. Same for the spending. They did not tell us whether they spend the same amount of money or not, right? So I wouldn't know whether this one here and this one here, would they be the same? Okay, and in the end, the after part, so the after part be the 4 and the 3. The 4 and the 3 is in the end. So we do not know whether in the end, they really have the same amount of money or not. All right. So there is no common base here at all based on our discussion. So if no common base, remember what we can use is we use units and parts. Okay. So in other words, these two ratios, you have to treat them as two different families. One family is units, the other one is the parts family. Because there is no common base to unite these two ratios together. Now, once this is done, we would like to work with the values that I have, which is the $1,000 and the $787 here. Okay, so let's figure out $1,000. What constitutes this $1,000? So remember, this $1,000 is at first, before. So we look at all the before. John's before is 5U. Peter's before is 4 parts. Hence, I can create an equation 5U plus 4P equals to that $1,000. Now we're going to do the same for the $787 here. So this is the in the end. In the end means I look at the after. Okay, the information in the after. So John's after is 4U. Peter's after is 3P. Hence 4U plus 3P. Okay, plus here. So 4U plus 3P equals to the 787.5. Okay, now in this case, the question is asking how much did John have at first? So when you have two equations presented like that, what you would like to do is your aim is to make either the units the same or the parts the same. Now, honestly, in this case, it doesn't matter which one you make the same because both equations show a plus sign. You are pretty safe. You don't have to deal with things like negative numbers or whatsoever. All right, so you can choose freely which one you would rather make the same. Now, but there's a quick tip here. All right, a tip here is if the question is asking for John, it would be easier to parts the same. Okay, because John is in terms of units. So if I make the other guy units, okay, the other guy is parts, Peter has parts. If I make parts the same, I would be able to get rid of the parts later on easily. Okay, so since we want to find John, we make parts the same so that we can remove parts easily later. So that's just a quick tip. Let's say if you don't want to stick with this idea, it's fine also. All right, you can still go on to make you the same. That's totally all right. Just that later on at the back part, you may have a little bit more steps to work your way around to find John. Okay, so for now, I'll just stick with this. So I'm going to make parts the same. So parts will be 4p, 3p is 12p, right? Common multiple is 12p. Hence, I times 3 to this, and I times 4 to the next one. Now, with that, I'm going to write down my two new equations. So everything here times 3, you get this. Second one times 4, you get this. So make sure every term must times also. Okay, so normally I'll draw a line to differentiate the old versus the new equations. So now looking at two new equations, since you have made 12 parts the same, notice that you can easily get rid of 12 parts by taking the difference between both equations. So 16u minus 15u, that's a difference of 1u. 12p minus 12p, no more p, you get rid of p. That's how you get rid of parts. You see, so that's the idea. When you make parts the same, you want to get rid of parts. And of course, whole number minus whole number, you get 150. Now, in other words, your 1 unit equals to this difference of 150. There you go. Okay, you have found 1 unit. Just nice. Once you have that, read back the final question. They ask you, how much did John have at first? So looking at John at first means John's before, right? This 5 units here. So I need to find the value of, okay, 5 units. And that will be the answer.